Hello girls, I hope you're staying safe at home. Now to continue with the electrolysis chapter, today we are going to start from electrolytic dissociation. Now electrolytic dissociation means the process by which an ionic compound you know how it is formed by the transfer of electrons. Okay, so ionic compounds dissociates or separates into ions in the fused or in aqueous state. Fused means melted, aqueous means dissolved in water. So this is known as electrolytic dissociation. This is your definition. Now, when we talk about the electrolytic dissociation of sodium chloride, remember sodium chloride is an electrovalent compound formed by the transfer of one electron from sodium to chlorine. Okay, and so it is crystalline in structure. It contains sodium ions and chlorine or chloride ions. In solid state, sodium chloride ions are not free but are held together by the chemical bond, the electrostatic force of attraction. So it does not conduct electricity. Why? Because there is absence of free ions. But when sodium chloride is dissolved in water, that is aqueous solution, or melted, that is fused state, it conducts electricity. Why? Because in the aqueous state, the slightly negative charged oxygen atoms of the polar water, if you remember, oxygen has 6 electrons in its outermost orbit. Hydrogen has 1. Okay, hydrogen has 1. So this hydrogen will be pulled towards oxygen. This hydrogen will be pulled towards oxygen having a slight delta positive, and oxygen will have a slight delta negative charge. So the slightly negative charged oxygen atoms of the polar water pulls on the positively charged sodium ions. So sodium ions will be pulled by oxygen. Okay, and a similar pull is exerted by the hydrogen ions. Hydrogen is positive, so it will pull chlorine ions towards itself. So the ions become free in solution. So these free ions conduct electricity, and when in the molten or melted state, the high temperatures required to melt the solid. Now to melt sodium chloride, high temperature is required. So as a result, the chemical bond between the particles becomes weak and the ions are set free. That is, sodium and chlorine atoms become free. The bond becomes weak. Okay, so as a result, free mobile ions are there, which carries the electric current. Now ionization. Now there are certain covalent molecules. Just now we talked about electrovalent compounds, electrovalent molecules. Now there are certain covalent molecules, if you remember, polar covalent compounds. Okay, they are not made up of ions. They are formed by sharing of electrons. They are not formed by transfer of electrons, so ions are not formed. But when they are dissolved in water, they form ions. Okay, so of course, when in the solution form, if they have ions, then they will conduct an electric current. Okay, so the process by which polar covalent compounds are converted into ions in water solution is known as ionization. Okay, remember, it is only polar covalent compound, not ionic compounds. So ionization is the process by which polar covalent compounds are converted into ions in water solution. Okay, and it is known as ionization. Example: hydrogen chloride. Now in the gaseous state or in pure liquid state, hydrogen chloride is unionized. Okay, and it does not conduct an electric current, because hydrogen has 1 electron and chlorine has 7 electrons in its outermost orbit. So they share the electrons. Hydrogen becomes duplet, chlorine becomes octet. So they do not have any free ions. Okay, so it is again polar in nature. Why? Because hydrogen has just 1 electron. So this electron is pulled towards the chlorine. So it has a slight positive charge, and chlorine develops a slight or delta negative charge. Okay, so it is a polar covalent compound. So when hydrogen chloride is added to water, that is a polar solvent. Again, water is also a polar solvent. It has delta positive and delta negative oxygen, delta positive hydrogen. The slightly negative charge of oxygen atom of the water, it pulls the hydrogen ions present in the molecule of hydrogen, chloride. And similarly, um, what happens? The polar covalent compound, that is hydrogen chloride, will break up into ions. So thus hydrogen ions combine with water to form hydronium ion. Okay, we had learned the formation of hydronium ions in chemical bonding, if you remember. Okay, now comparison of ionization and dissociation, children. This table is important. So ionization means formation of positively or negatively charged ions from molecules which are not in the ionic state, they are covalent. But when we talk about dissociation, we are talking about the separation of ions which are already present in an ionic compound. Okay, and ionization is seen in polar covalent compounds. Okay, but dissociation is seen in electrovalent compounds, and examples are given here. Just like we have the activity series of metals, in electrolysis there is an electrochemical series. Okay, now metal elements lose electrons from the outermost shells of their atoms, you know that. And when the metals lose electrons from the valence shell, what happens? It forms a positive metallic ion. That is potassium. When it loses one electron, it turns into K plus. Similarly, calcium Ca2 plus, sodium Na plus, magnesium Mg2 plus, aluminium Al3 plus. So to turn these ions back into the atomic form, how many electrons must be gained? Here 1 electron, here 2, here 1, here 2, here 3 accordingly. However, the tendency to lose these valence electrons varies from metal to metal. Okay, how will it lose? Which one will lose first? Supposing in a solution you have potassium, you have calcium, you have sodium ions. Now which one is going to lose the electrons first? Okay, or gain the electron first? So that depends from metal to metal. So the metallic elements are arranged in decreasing order of their tendency to lose valence electrons. Valence electrons means the electrons which are found in the outermost orbit. So you see here in the electrochemical series of metals, sodium gets converted to sodium ion much more easily than copper to copper ion. Zinc becomes zinc ion more easily than silver to silver ion. So based on how easily with which atoms of metals lose electrons to form positive ions, the metals are arranged in a series which is known as the electrochemical series of metals. So here you see, okay, this is the electrochemical series of metals. It is similar, if you see, to the activity series of metals. Okay, so increasing ease of discharge at cathode. Okay, as you go down, it is more easily discharged at the cathode. Okay, so remember, a metal with higher position in the series displaces the one with a lower position, that you already know in displacement reactions. Okay, metals below hydrogen cannot displace hydrogen from acids, while those above it can. This is more or less discussing the activity series of metals. Elements lower in the series, now this is important for your electrolysis. Elements lower in the series gets discharged more easily at the cathode during electrolysis. Why? Because their cations can easily gain electrons. This is important for your electrolysis. Metal atoms which form their ions most easily will accept electrons back to form the atoms with greatest difficulty. So metals which form their ions most easily, the one in the highermost in the activity series, potassium, sodium, they can easily form ions, but they will have difficulty in accepting the electrons back. Okay, then hydrogen has properties of metals because it forms a positive ion, so its position is there amongst metals. That is why it is in the activity series of metals, even though hydrogen is a non-metal. So that is why it is placed. Why? The only reason is because it forms a positive ion. It has only one electron in its outermost orbit and it can easily give away that electron. Now, electrochemical series of anions, that is the negative charge. Okay, anions are negatively charged ions. So anions, A to A anions moves towards the anode, the positive electrode, so they lose their extra electrons or negative at the anode, and they are discharged there. But all anions do not have the tendency to lose electrons. So based on the tendency to lose electrons and gets discharged at the anode, again they have been arranged in another series which is known as electrochemical series of anions. So here you can see sulfate, nitrate, chloride, bromide, iodide and hydroxide. So as you go down, the one which is lowest will be discharged first. That means if there are nitrate anions and hydroxyl anions, which one will be discharged first at the anode? Hydroxyl will be discharged first. After all the hydroxyl ions have been discharged, then only nitrates ion will be discharged. So lower the position of the anions in the series, more easily it gets discharged at the anode, and higher the position of the anions in the series, more difficult for it to lose electrons and get oxidized. Okay, so preferential or selective discharge of ions at electrodes is what I already discussed here. Which metal or which non-metal will get discharged first? When two or more ions of the same charge are present in a solution of an electrolyte under the same conditions and they are to be discharged at the same electrode, then of course in the beginning one has to get discharged first. So this is known as selective discharge of ions. Okay, so remember, selective discharge of ions depends on three factors. First is the relative position of ions in the electrochemical series, the activity series that we just discussed. Next is the relative concentration of ions. Now which has more concentration? Now if there are lots of sodium ions and very few copper ions, then naturally the one which is more concentrated will get discharged first. And next is the nature of the electrodes. Now the relative position of ions in the electrochemical series, now if all other factors are constant out of the three we just discussed, any ion lower in the electrochemical series gets discharged at the electrode which is above it. So if you look at the electrochemical series, the one which is lying below will get discharged first, be it anions or be it cations. Okay, now for example in the electrolysis of copper sulfate solution, okay, so you can see copper sulfate will dissociate into copper ions and sulfate ions, and water will dissociate into hydrogen and hydroxyl ions. So here how many positive ions do you see? You see two positive ions, that is copper and hydrogen, and you see two negative ions or anions, sulfate and hydroxyl. So what will happen? Copper and hydrogen will migrate towards the cathode. Okay, but copper being lower in the electrochemical series will be discharged. Understood? So this is lower in the electrochemical series, so this will be discharged. And at the anode again, both sulfate and hydroxyl will migrate towards the anode. But which is lower in the active electrochemical series? Hydroxyl is lower in the um, electrochemical series, so that will be discharged first. Okay, so what will happen is hydroxyl ion, it will lose and it will become OH. Okay, two OH will come together to form water and one nascent oxygen, and two oxygen will come together to form oxygen gas. Okay, and at the cathode, reaction at the cathode, copper is getting discharged, so it had lost two electrons to turn into copper ion, so it will gain back the two electrons and it will turn into copper atom. That is a reddish pink metal will be seen depositing at the cathode. Now, when we take the concentration of ions in the electrolyte into consideration, remember, if an electrolyte has a much higher concentration of a particular ion, then that ion will be discharged at the relevant electrode, wherever it is to be discharged, in preference to those ions which are lower in the electrochemical series but present along with it. Okay, so if we take the example of electrolysis of concentrated sodium chloride solution, so sodium chloride will break up into sodium and chloride ions. Water will break up into hydrogen and hydroxyl ions. So the positive sodium and hydrogen will migrate towards the cathode. Okay, but even though there is high concentration of sodium, hydrogen gains electron more easily than sodium, because you know that sodium is more reactive than hydrogen. So it is hydrogen that accepts electrons more easily than sodium. Okay, so hydrogen will gain one electron and turn into one atom of hydrogen, and two atoms of hydrogen will come together to form the hydrogen gas. So overall, what will you see? Hydrogen gas will bubble off, effervescence you will see at the cathode due to the formation of hydrogen gas. And at the anode, the positive electrode, the negative ions will migrate, the anions, chlorine and hydroxyl. But again, if we look at the concentration, you will see that chlorine is at a much higher concentration than hydroxyl ion. So chlorine is discharged, although hydroxyl has a lower position in the electrochemical series. Okay, so chlorine will lose one electron and form one atom of chlorine. Two atoms of chlorine will come together to form chlorine gas, which is a greenish yellowish gas you will see being discharged at the anode. Now next is the nature of electrodes used. Electrodes used in the process of electrolysis may be either inert or active. Inert means they do not react, they do not take part in the electrolysis reaction. So electrodes used determine the ions preferred for discharge. So if inert electrodes, example of inert electrodes are graphite and platinum, they will not take part in the electrolytic reaction. Inert, they do not take part in the reaction. So the electrolysis will depend only on the two factors, that is position in the electrochemical series and concentration of ions. But if active electrodes like copper, nickel, silver is used, they take part in the electrolytic reaction and the product formed is completely different. Now, in the electrolysis of copper 2 sulfate solution, if active electrode copper is used, if active electrode copper, we are using what electrode? Copper. Then copper atom is deposited at the cathode and copper ions are formed at the anode. When we do take up the examples of electrolysis later on, we'll be discussing the electrolysis of copper 2 sulfate using both active as well as inert electrodes. Okay, so if inert electrode platinum is used, then instead of copper ions, oxygen is formed at the anode. Okay, today I stop here, children. We'll continue in the next upload. For your assignment that you are supposed to submit this Saturday, you are going to write down the definition of electrolytic dissociation and also explain the electrolytic dissociation of sodium chloride and why it doesn't conduct electricity in the solid state and how it conducts electricity in the aqueous and the melted state. And also write down the electrochemical series of metals and anions, and you'll submit it this Saturday. Till then, children, stay safe. God bless you.